Hello again. Welcome to another lesson in Algebra 1. Today we're covering section 3.4, solve equations with variables on both sides. Alright, so your warm-up was to solve each equation or simplify each expression from 1 through 4 here. So, number 1 is an equation. It has an expression on both sides separated by an equal sign that makes an equation. We did a lot of stuff with expressions in chapter 2, so we're trying to remember that the difference between equation and expression. This is a two-step equation, so I'll add 12 to both sides to get 55, and then I'll divide both sides by 5 to get 5. Okay. Number 2, this is an expression, so all we do is simplify it. We're not trying to get x by itself, notice there's no equals in another side. Okay. So I'll copy down 3x, I distribute the 7 to get 14 minus 7x. I combine the like terms, 3x minus 7x makes negative 4x, and I bring down over 3. Number 3, this is an equation. At the right side here, we have to do some distributive property first to help us out. So I'll divide both sides. I'll go ahead and multiply 3n to make 15x plus 3. And then I'll subtract 3 to both sides. Another two-step equation now. It's going to be equal to 15x. And then divide both sides by 15 to get 2. Now you could also have done it this way, another way, I'll show you. We have multiply and we have a grouping symbol. So we could undo the multiply first to make this 11 equals 5x plus 1. And then solve the two-step equation. So subtract 1 with the less 10. And divide by 5 with the less 2. Notice both ways we end up with 2. Alright, number 4 is another expression. Notice no equal sign with another expression on the other side. So we combine our like terms, 6x and minus 9x put together to make negative 3x. And then plus 8 and plus 2 go together to make plus 10. Alright, so what is the difference between an equation and an expression? So an expression is created from numbers, variables, and operators. An equation is two expressions combined with an equals. So the difference is the equals part. Equals is not an operator. Alright, second page. Solving equations with variables on both sides. So when there are variables on each side of the equation, it can be harder to determine where to begin the problem. Okay, so the key here is to move the variable term off of one side of the equation. This can be done with adding or subtracting this term from both sides of the equation, and then we solve the normal two-step equation. To recap, one more time, we have the following steps. Simplify both sides of the equation. Move the variable term off of one side of the equation using either add or subtract. Okay? And then finish by solving the remaining two-step equation. Here's a complete example for you. I have 8x plus 10 equals 6x plus 4. Notice I have a variable on each side of my equation. But each expression on each side of the equals is already simplified. 8x plus 10 have no like terms, and 6x minus 4 have no like terms. So my inverse operation is to subtract 6x from both sides. Okay, I picked one of the variables, so I chose to use the 6x side. I subtracted 6x, so that left me with just negative 4 on the right side. And on the left side, 8x minus 6x makes 2x, and then we bring down the following 10. And now our result is a two-step equation. So we finish by solving that two-step equation. So add or subtract 10 to both sides to get negative 14, and then divide by 2 to both sides to get negative 7. Now, the next one's a little example is a bit trickier, because first we need to simplify each side of the equation. Okay? So the left side, notice, is not simplified. I have 6 outside in parentheses. Same with the right side. So I'm going to do the distributive property here. So 6x plus 30 is the left side. And negative 2x plus 6 would be the right side. Be careful when you distribute the negative, it changes the sign of both things inside. Okay? And then I'm going to move all the x's to the same side. This time I chose to do it with adding, but you could subtract 6x to both sides still. Adding 2x I think is easier because it leaves me with a positive number of x's at the end. So 6x plus 2x makes 8x. I bring down the 30. Over here, the negative 2x and the plus 2x cancel out. And I bring down the positive 6, but I don't like plus. And then I subtract 30 to both sides to get negative 24. And divide by 8 to both sides to get negative 3. Okay. All right, so a few examples to demonstrate this more complicated form. Let's do these together. Okay. And then I'll have you try some and check your answers. So first thing we're going to do, we have 10x plus 6 is equals 6x minus 4. Both sides are simplified. Okay? No like terms on either side can be combined. You could do minus 10x to both sides or minus 6x. I always pick the smaller one. It ensures that the other side will end up with positive numbers. Okay. So this will give me 4x plus 6 equals negative 4. Don't forget these two cancel out, but the negative 4 is still there. Subtract 4. Then you subtract 6 to both sides to get negative 10. And then divide by 4 to both sides, and 4 goes into 8. 4 goes into negative 10, negative 2 and times. Number 2. Same thing. 7x plus 6 equals 4x minus 9. Normally I would do minus 4x, so I can have positive x's on the left side. I'm going to go ahead and do minus 7x just to show you that it'll still work out. So this will make 6 on the left side. On the other side, I get negative 3x minus 9. And then I add 9 to both sides to get 15 equals negative 3x. And then I divide by negative 3 to both sides to get negative 5. Number 3 is a bit different. Notice on the right side, we have only an x term. When that happens, it's much easier to move all of the x's to that side. When you're done, you're going to get a one-step equation remaining. So then I would divide both sides by negative 2 to get negative 2. Be a very quick problem. At some point during the year, you're going to do this a little bit different, and then you're going to wonder what's going on, so I'm going to show you. Let's say you did minus 3x to both sides. Then on this side, we have 2x plus 4. Well, the other side, what's still over there? Nothing. 3x minus 3x cancel out, so you write a 0 x spot. You can then solve the two-step equation. Divide both sides by 2, and we get negative 2. Same answer. Now, a lot of times people will do this part, get the 2x plus 4, and then they say, oh, that's gone. And they don't know where to put the equals, so they just change the plus to equals. Be careful. You just put a 0 placeholder on the right side if you start one for that problem. Okay? All right, number 4. First, I'll distribute to simplify the left side. Right side is already simplified. I'm going to add 5x to both sides, because that's the smaller amount of x's. Give me 7x minus 6 equals 1. Then I'll add 6 to both sides to move the 6 away from the x side. Okay? And then I'll divide by 7 to both sides to get the x isolated by itself. Alright, so now you should pause the video and try these 4 problems, and then come back and correct them afterwards. Alright, welcome back. Alright, so hopefully on this one you might have done either minus 14x or minus 20x to both sides. Okay. If you did the minus 20x, just watch and see if you get the same answer at the end. You'll know you did it right. So we have 22 plus 6x. Divide both sides, or subtract 22 to both sides, you're going to get negative 36x. And then I divide both sides by 6, I'll get negative 5. So if you had done it the other way, you would have ended up with negative 6x minus 8 equals 22. And then negative 6x equals 30. And then x equals negative 5. Still get the same answer. All right, number 6, hopefully you simplify the left side first. So 8x minus 20 equals 3x plus 10. And then I'm going to do minus 3x to both sides. So will give me 5x minus 20 equals 10. Now, you're not required to show this minus 3x step, but I always put it on here because it's a new thing that we've been working on. So then I'm going to get 5x equals 30 and x equals 6. Same thing as before, you could have done minus 8x on both sides. You should end up with the same answer again. All right, number 7, I've got 6x plus 24 equals 8x. Notice on the right side I have only x's, so I'm going to do the minus 6x. So I end up with a 1 equation. Then I'll divide both sides by 2 and 12. Our last one, we have 63 minus x, that's simplified. And 2x plus 3, that's also simplified. So I'm going to do plus x to both sides. This will give me 63. And 2x plus x is 3x. And then we got the plus 3 still over there. Subtract 3 to both sides will give me 60. And then divide by 3 to both sides to get 20. Now once again, you could have done minus 2x to both sides and you end up with a negative reaction to both sides. Or when you're done solving, you get the same answers. All right, equations do not always have one solution. An equation that is true for all values of a variable is called the identity equation. And it just means that both sides of the equation are really the same. So the solution of an identity equation is all real numbers. And sometimes equations have no solutions at all. Okay? So we're going to solve each of these equations if it's possible. Okay? So on the left side here we get 3x. On the right side we get 3x plus 12. Our first step should be to subtract 3x from both sides. And we get 0 equals 12. Notice all of our variables canceled out. That's what happens when we end up with one of these special answers, all real numbers or no solution. Okay? So when all the variables cancel out, we look at what remains. And in this case, is this what remains a true statement? That's no. 0 is never going to be equal to 12. This is no solution. And the reason is, no matter what x you pick, the right side will always be 12 bigger. So for instance, if I pick 3, the left side would be 9. And then 3 plus 4 is 7. 7 times 3 is 41. There's a difference of 12 in those. No matter what x you pick, you plug it back in, you're going to find the difference of 12. All right, number 10. Start by simplifying the right side. At this point, you could probably notice that it's going to be an identity, all real numbers for our answer, because both sides look exactly the same. So if I subtract 2x from both sides, I get 10 equals 10. And obviously, this is a true statement. So it doesn't matter what x I pick. No matter what I plug in, I always get the same on both sides. So this means that the real solution is all real numbers. So remember, real numbers are any number that we've talked about so far in math. Okay? So there are some non-real numbers, but we haven't reached them. We'll see it in the algebra too. Okay, let's pick a number just for random and plug it in and show that it works. So let's say I pick 7. 2 times 7 is 14, plus 10 is 24. Over here I do 7 plus 5, which is 12, and 12 times 2 is 24. No matter what I pick, I always get the same number on the left, the same number on the right, which means all of the numbers are solutions, and that's why we write all real numbers. 7 was one of my solutions, but there's infinite numbers. Okay. All right, number 11, I get 9z plus 12 equals 9z plus 7. When I'm done subtracting 9z to both sides, I get 12 is equal to 27. Obviously, that's not true. So a little x there, and write no solution. And in the last one, I subtract 7w from both sides. I get 1 equals w plus 1. This is not a no solution or infinite solution or all the numbers answer here. This is subtract 1 from both sides and we get 0, and w is 0. So the only thing that makes this equation work is 0. It has only one answer. Okay. Number 9 and number 11 had no answers that make it work, and number 10 has all the answers to make it work. Okay. All right. Now, for follow-up, you need to get on Khan Academy, and you need to start the conscious recommendations equations with variables on both sides. This assignment will be due the morning after the next class. So I'll give you today, and then in some class time, and then after class you can work on it until the next morning, and then I'll get all the grades in the morning. Okay? So make sure that you get that part practice. So we'll see you in class next time.